Okay. Hi, everyone. Good evening, and welcome once more to our final and last session on the online sessions of React Native Developers Bootcamp organized by Tech Chantier. Today, we're going to have one of our finalists. He's going to be giving us the introduction to TypeScript. You've been doing a lot of JavaScript, but it's important that you understand how to use TypeScript so that you can ease your development and debugging time. Engineer Desmond, he's the founder of Hustler Engineering Community, also the founder of Lambda, a tech organization that deals with development of web, mobile, enterprise AI solutions. So you're going to learn a lot from him today. Ensure you pay attention. This session is being recorded, and we're going to share it also on the group and also on our YouTube channel. So without much ado, let's put our emojis together, and we welcome Engineer Oben Desmond on the floor. Thank you, Desmond. Over to you.
All right, thank you guys so much for having me. And I hope that I can try my best to give you guys what TypeScript is about and how you guys can be able to use TypeScript in your own projects. Thank you very much for having me. So, without further ado, I think I should, without further ado, I think we could start. So, a little bit about myself. I think that Engineer Martin has already done the intros, but I'm a software developer. I've had to work with a couple of companies here in Cameroon, like Bayam, and other companies out of Cameroon, like Infinex Partners. And we heavily use JavaScript and React. I've used JavaScript on the front and the back end. So definitely JavaScript is something that is it's a very popular choice. And React and React Native particularly are very popular choices among developers. So I think that you guys are on the right track in your careers, and kudos to Tech Chantier for picking the right framework to teach you guys. So a little backstory on why I think TypeScript is really important. 5 years ago, I started on my own journey to build mobile and web applications. Got to learn about React and JavaScript, and like very shortly, I could be able to clone my own applications. I was able to clone things like YouTube, and started building my own apps. And at some point, I built this app that had about 700 users. And after a while, people started complaining that it was crashing, and we had to go in there, dig inside, and try to find out what exactly was wrong. And after like 2 to 3 days of digging in, we realized that there was just this little error where instead of something, being like we're looking at, so it was basically views for past questions. So the views are in numbers. So you can have like 1,000 views or 100 views. So we had to now divide it by, 1,000 so that we can have the views in K. So it would be like 0.5K or 100K and all of that. But then nothing was, for this particular past question, there was no value, there was null. So you can imagine dividing null by 1,000 and you put this error, and we only realized that a lot of people were complaining because they ran into this issue. And we realized that if we had TypeScript, we were using TypeScript on our, on our code base, it would have made things a lot easier. So we had to send a lot of apologies to the people that were using our apps, and TypeScript is so important because of this particular issue that it was able to solve. So what is TypeScript? I mean, you've been hearing TypeScript. It sounds very similar to JavaScript, and that's because it is. So TypeScript is like, just from the name type, JavaScript is a language that is not typed, it's very loosely typed. So if you're from a background like C, C++, you realize that they always start their things with like ints or string. That's because by default, the programming languages are meant to be typed, very typed, so that you don't have to make issues like giving a certain variable and integer when it's supposed to be a string and all of that. So TypeScript is what the version of JavaScript that brings order when it comes to the level of types. So TypeScript is like a smarter version of JavaScript that helps you catch mistakes before your code runs. So there's a compiler that compiles your code, and if you have any issues like wrongly typed JavaScript, it's actually able to tell you. So that's how that works. And you can look at JavaScript to be like the Grammarly of TypeScript to be the Grammarly of JavaScript, because just like when you're writing an email or you're writing something in a document and you have like Grammarly installed that tells you that, okay, this is not correctly spelled, the grammar is not correct, It's the same thing with TypeScript. TypeScript tells you when your types are not correct. And trust me, it's actually been very helpful. It's going to really make your development speed quite fast. It may not seem like that in the beginning when you're learning, but eventually you get to realize like that's that fast. So if you could look at in another way, like another analogy, like P square and where you have Mr. P and Root Boy, I think that if you follow P square, you should know that Root Boy is the person that sings more. But without P square in it, there's really not going to be that choreography. It's not the same. So you can look at it as there is the brother who is like, coming to bring in order to the way things are run as far as the JavaScript programming ecosystem is concerned. So I hope I was able to really break things down. It could get really confusing for some people, but that's basically how the difference between TypeScript and JavaScript is. So if we have to look at the code because we're developers, I mean, we don't just talk theory in the air. So with JavaScript, you have something like let item equals to apple. So you realize that item can take a string, which is apple. An item can also take a number, which is 1 to 3. But under normal circumstances, that should not happen. I think some types, some variables should actually have one type. Is there a question?
Yeah, I think, are you still on the first slide or is my screen frozen?
Oh, I'm on the second slide.
Okay, can somebody see the second slide because mine is still showing first? I just want to be sure it's not my screen. Hello, can we see second? Are we on the second slide?
No, sir. No, sir.
Yeah, this one, I think yours is still showing the first slide. We're still TypeScript for beginners.
Interesting. Okay, let me see what to do about that.
Yeah, I think everybody was on the first slide. Maybe you just try to share again.
All right, so it means that you guys didn't see the whole thing I did about P square and everything.
Yeah, we're looking at where's the P square.
Okay, please let me know if you can see my screen.
Showing just blank. Yeah, it's still showing just blank. Not sure.
That's interesting. What could be wrong? Let me stop sharing and try sharing again.
Maybe try share your entire screen if you don't have any sensitive.
Actually, initially I was sharing my entire screen. But let me just share my entire screen again. Okay. Okay, please let me know if you can see my entire screen.
Okay, we are on show me the code. Can somebody say show me the code? Okay, just so we are sure, just go to the previous, let's just go to the previous slide. Let's see.
Yeah, I'm on
Okay,
the previous slide. Okay.
Okay. So I think it's now.
Okay, great. So this one I was talking about the whole piece thing. Now I'm going to just move forward. Okay, so let me restart back what I was talking about, the difference in terms of the code, JavaScript and TypeScript. So if you're working with JavaScript, you can be able to realize that if you look at the code to the left, top left, we have let item equals to apple. That's the first line of code. And you realize that apple is a string and we're assigning apple to item, the item variable. And then in the next slide, we have the next line, we have item equals to 1, 2, 3. And we realize that 1, 2, 3 is actually a number, not a string. And this is normally okay if that's what you intend it to be, but this could actually be a mistake. So usually with TypeScript, it comes to tell you that, okay, if this is actually supposed to be a number, tell me that this is a number. If this is supposed to be a string, tell me beforehand, so that in case you make the mistake of giving it a string instead of a number, or a number instead of a string, then I should be able to tell you that you're actually making a mistake. Yeah, so if you look at the line, the next line, where the next box with TypeScript, it shows you like let item, and it actually shows you the TypeScript connotation for giving a type to item, which is string. So we're saying that, okay, item is a variable, but it's not just any variable, it's a string. And I'm going to initialize it with an apple, which is a string. And if I come and I say item equals to 1, 2, 3, this is not correct. This is not fine. So the compiler is going to tell you that this is not correct. So That is the main difference between JavaScript and TypeScript, is that we're trying to write a little bit of code that is going to help tell us that, or tell the compiler that this is the way I actually intend it to be. And in case I'm going out of track, then please let me know. So that's how TypeScript works. I don't know if there are any questions so far, and if you can be able to see the next slide.
Yep, yep. Can see the next slide. You're on install npm now, right?
Yes, 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 I am.
Okay.
I am.
Thank you.
Okay, so usually there are different ways in which we can actually work with TypeScript. If you're working with on a React project, for example, you can be able to install your project directly with TypeScript. That's still fine. You can be able to work on another project, a JavaScript project. It could be using another framework like Vue.js or Angular, and you can be able to install. It has its own procedure for installing TypeScript. So when I was creating this document and the whole presentation, I wanted to go bare because I didn't know how far you've gone with React. So I just wanted to show you guys how this works with, like, bare JavaScript. If you want to just like play around with TypeScript without having to install like a framework or all of that thing, you can actually do that with the minimal setup. Yeah. I think there's some interference somewhere. Somebody's mic is on and it's giving the call. So if you mute. I think that would be Princely. Thank you very much. Princely, could you mute? I'm having a lot of interference from your end. Okay, thank you. All right, so basically, I think Martin, I was texting with Martin, then I think I got busy. So he was like, I should use React, but since I don't have like a bare React project, I'm just going to follow these guidelines so that I can have like a project set up for you guys so that we can see how it works and all of that. So it's basically simple. The first thing that you need to do is install npm. Npm is short for Node Package Manager. If you're dealing with a JavaScript project, so if you're doing something with React, you're going to be using npm to install all your packages. So I don't want to go too deep into what npm is about and how the whole npm ecosystem works, but the first thing that you need to do is to install npm. And for you to install npm, you need Node.js installed. I'm going to skip through that process because I believe that it's going to be covered if it has not already been covered in the curriculum for the React Native Bootcamp. But the first thing that you need installed is npm. And for you to be able to do that, I'm just going to pop up my terminal here, and I'm going to pop up my terminals and show you guys how I can test for npm being installed. All I need to do is do npm -v, and if it shows me the version number here, it therefore means that npm is installed. And yeah, so if you install npm correctly, you should be able to do npm-v and or npm -- version. So if you like doing things the old school way or the longer way, you can do npm -- version, and it should give you the version code as well. So that's how I can be able to tell if I have npm installed. So I'm going to move to the next thing, which is installing TypeScript. So TypeScript is, this line of code is installing TypeScript globally. So if you want to have TypeScript available globally so that you can compile anywhere in your project, then you want to do npm I, which is short for install, and -g means you're installing it globally, and you can now put TypeScript. It's going to install the TypeScript CLI so that you can be able to use the TypeScript compiler to compile your JavaScript code. So you can just copy this and you paste it in your terminal to install TypeScript globally. And fortunately, I already have TypeScript installed, so all of this installation process is not possible. And it's also good because we get to save a lot of time. But I'm going to, I think this document is going to be made available. So in case you want to do that by yourself, you can actually go in and read yourself. The next thing you want to do is to test if your TypeScript is actually installed correctly. You need to do tsc-v, which is to find the version for your TypeScript configuration, which is 5.7.2, meaning that we have TypeScript installed successfully. The next thing you want to do is to create a directory. And if you don't know how to create a directory, you can actually use your file explorer to do that, or you can use your terminal by using mkdir, which means make dir. And you can call this whatever you want. I just call it Typescript project. You can decide to call it however you want to call it. So I'm going to copy this and make sure that I want to seed into my desktop so that it's on my desktop. Then I'm going to paste that command so that I create a directory on my desktop called Typescript project. Then the next thing that I want to do is to get into the directory. So I'm going to get into the directory by copying this and pasting here. And finally, what I want to do is to open my directory with code. So there are two ways to do this. You can either go to your desktop, wherever you're doing this, create your directory and seed into your directory and open that, your VS Code on that. But if you have VS Code stored in your path, then you can be able to do something like code dot, and you should be able to just open VS Code. So I'm going to show you guys both ways, just in case you don't know how to do that using your path. Yeah, and I'm also going to show you like while you're inside VS Code. So if I do code full stop, meaning that I'm opening the VS Code instance, full stop means in the current directory. So clicking that is just going to automatically pop up my VS Code in that folder. As easy as that. And I don't know why it keeps telling me that like this is something that pops up a lot. Do you trust the authors of this file? I mean, I just created the file. So yes, I trust the authors. So I have my TypeScript project, very blank and empty project created and open there. Now, what if I wanted to just like open this using my File Explorer? Very simple. I click on the open. I open VS Code first of all. I click on open. Then I go to my desktop where I have that installed. Then I can click on TypeScript project, and I just open it because that's the project I just opened. We could literally just create an empty folder and open it here, and that will still be fine. So I don't know if we have any questions so far before I go into like creating the files and running the files. So are there any questions as far as the installation process is concerned? Let me open it up like this. Any questions? So if you have any questions, you may want to raise your hands or you unmute your mic and start talking, because I cannot really see the Google Meet because I'm actually sharing this. So yeah, if there are any questions, you can always stop me at any point. So yeah, I'm going to close this and we're going to focus on this folder. So I believe that all of us are using VS Code, and VS Code is a code editor. You can call it an integrated environment for writing your code, and you can be able to have like compilers and extensions and all of that thing. But basically, VS Code is used to write code. So I'm going to go into it and show us how like this works, how we can be able to have our TypeScript, our very first TypeScript file to work. So you want to go in there and put an index.ts. You can call it whatever you want. You can call it text shanty. You can call it Martin. You can call it Ferdinand. It's all up to you. So I'm going to call it index because index is what I want to call it. And you can use TS. TS means TypeScript. I think that when you're building your React native applications, your React applications, you may see people using TSX because it just means JSX, which is just like React stuff, but now with TypeScript it's TSX. So that's how it works. So I'm going to use TS because I'm just building a normal TS file, and I'm going to create a JavaScript file as well because I want to show you how there's a difference between the TypeScript and the JavaScript. So first things first, I want to be able to create an integer. So we're going to have a similar example like we had there. Let me make it bigger so that all of us can see. So I'm going to create a name, a certain name, and I'm going to call it, let me use underscore name, and I'm going to call it text shanty, right? So with JavaScript, you can decide to put the colon or you decide not to put the colon. I don't know who gave them the idea of that redundancy, but it's all up to you. So I'm going to also give assign name the value 1, 2, 3. Now, basically, I can come here and do a call to the log on name, and this should work very fine, right? So I have to save my file. I come to my terminal. So if I have to run this, I believe that the TypeScript compiler should compile like JavaScript code, but I'm not sure. So I'm going to try index.js. It doesn't work. Why doesn't it work? TypeScript, I'm in the TypeScript folder. Okay, let me try compiling the index.ts. Okay, not TS. Oh, it is TSC. Sorry, TSC. All right, so it compiles the TS file, but not the JS file. So you may want to use Node instead. You can use Node and you do index.js if you want to just compile your JavaScript, and that should give you the value. Sorry, I'm supposed to save this, not keep this. So if I run that command again, node index.js, I should be able to see 1, 2, 3 printed. So basically, what I'm doing here is just creating a variable, giving it an initial value, and reassigning it to another value and logging that value out. Now, this is something that works normally, but what if I actually wanted this to be like just a string, and if I wanted this not to be a number, and I by mistakenly made it a number? There's no way that JavaScript can actually stop me while doing that. But with TypeScript, on the other hand, I can be able to come here and I do let underscore name, and I say this has to be a string, and I say the name is Tech Shanty. Thank you very much. And the name, I come and reassign it to 1, 2, 3. Then I can console log it. And if I try to run this using tsc index.ts, I mean, it should throw me an error. And it found an error here, and there was an error saying the type number is not assignable to type string. So basically, that is where TypeScript comes in. I think there should be a way that we can get rid of this little underlining here. Block scope variable. Okay, let me try to use another variable name string. I hope this works. Okay, so apparently the red line is showing because apparently there's some other okay, so we have like real time telling us that this is supposed to be a string, not a number. So initially, I think that probably the block scope thing was having an issue, but this works now. So without having to run it, the editor that I'm using, VS Code, already recognizes that I'm making an error here. So before I even go to run the code and everything, it just tells me that, dude, you have to look at this. This is not correct. So I have to change this to name str as well. Apparently, there's another variable that has like underscore name, so I cannot use it another time. So that's how TypeScript works. And we're going to look at the various types that exist so that we can know that, okay, we want to give this a string, we want to make this a number, this is how we actually do it. And I want you to take note, very extra note at this connotation here. So if I have to open this to the right, so if I have to split to the right, I will look at the two different codes, right? So let me just give it exactly the same variable name so that we don't get confused. So realize that to the left here, we have a name string. Oh, I now see why we're having an issue is because they are both in the same folder. So my VS Code is actually looking at the scoping, as in this has like index.js has the same variable and this has the same variable, so this should not work. So what I'm going to do is I'm going to differentiate it by giving one an underscore so that the red line on the other end can disappear. And we see only red lines for legitimate errors. Yeah. So we realize that the only difference that we have between these two as far as the code is concerned is this guy here. So whenever you want to be able to say that I want to make this a string or I want to make it an integer, you need to add a colon followed by the actual name of the type. So if this has to be a number, then I have to put number here, right? I realize that it just moves the red to the first line, meaning that I'm saying that name string should be a number, but why am I giving it a string? So the compiler is like, something is wrong on this line. So you can give it as many types as possible. We're going to go like into the types in a short while, but I just want to be sure that we understand the difference between TypeScript and JavaScript and why TypeScript is very important in helping us to find these issues. So I don't know if there are any questions so far. I can be able to take any questions now. Any questions? If you can still hear me, like, you should indicate because I may have been talking for the past 13 minutes on my own. Mr. Martin, are we still there?
Yep, we are here.
All right, I was almost worried there. Okay. All right, I think your hand is raised.
So my question goes, why the need for TypeScript? Like, I'm sure the compiler understands that we are assigning a string whenever we assign a string. So why the need
Okay, so if I get the point, you're saying why the need for TypeScript? As in, why is TypeScript important that the compiler should know as well, should know already? Is that what you're saying?
Yes, sir.
Actually, the compiler does not know, right? The only compiler that can know is the TypeScript compiler. So the compiler for normal JavaScript is Node.js, for example. Node.js is what compiles it so that we can be able to see the results. So if I run the Node.js part of things, index.js, right, this index.js, Node.js is going to tell me that everything is working fine and cool. Like you can go on with everything. So it doesn't realize that name string being 123 could probably be an error. Without TypeScript, the compiler, the Node.js compiler cannot know that there's an issue. Do you see the difference now?
Yes, sir. I've seen it.
Exactly. So yeah, so the compiler will not know. You can, like I said, we're building this and we launched it, and it's only when it went on production that we started seeing this. So yeah, another question, please go ahead. Hello.
This my question is, if we want to run TypeScript, we cannot, that means we have to install the TSC package the way we did for probably like to run JavaScript. We have to install Node. That means for TypeScript we need to install TSC, and if we need to install it, like how do we do it? Or by default, when you already install TypeScript globally, the compiler is already there.
Yeah, exactly. That is it. So when you install TypeScript globally, you have access to TSC. Even if you install it locally, whichever file you installed it into has the TSC. So TSC comes with the TypeScript installation. I don't know if it's understood.
Yes, yes, understood.
Okay, great. All right. In the absence of any other questions, I'm going to move forward, believing that the assignment has been understood. All right, so let's talk a little bit about the TypeScript compiler. We've been talking about compiler this, compiler that. Okay, so the TypeScript compiler is a compiler basically is something that actually checks the code to make sure that everything is okay, then produces another, a build that is more friendly to the production environment. So TypeScript has its code, and when you pass it through the compiler, it goes and checks if there's an error. So when we were doing TSC, whatever we were doing there, that was the compiler. So TSC means TypeScript compiler. So when we pass the TypeScript code, it has to be processed by the compiler. The compiler will either tell you that there's a problem, we cannot move forward, or it's going to convert the TypeScript to a JavaScript version, and then that JavaScript version can run on the browser. Now, the reason why it does is because not all browsers can understand TypeScript. So because of that issue, we need to have it in a way that it's understandable to whatever the browsers are running on. So we need the TypeScript compiler to be able to do that. For JavaScript, we have Node.js. The browser has its own version of Node.js, but you can be able to have like a Node.js running in your terminal and everything, and that compiles it to something that your, whatever is processing it can understand. So that is why we need the TypeScript compiler. So most times, TypeScript is not the thing that runs in your browser. It's JavaScript, but the compiled version of JavaScript. So that's why we needed to install TypeScript, which came with TSC, and from there we can be able to easily, process the TypeScript. So let me show you that in action. I'm going to get rid of this index.js, right? I'm going to delete it completely. So I'm going to move it to trash, and I'm going to save whatever we have here. I'm going to make it actually correct this time, because if it's not correct, it's not going to run. So I'm going to get rid of this. Maybe I make this a string so that we have access to like an actual string 1, 2, 3. Then I'm going to clear my console so that we are not mixed up anywhere. And I'm going to do tsc index ts. Great, so we have tsc index.ts. But I want you to also realize that on the left-hand side, we have an index.js that's been created, right? And this index.js is just like the JavaScript version of index.ts, which is like the TSC compiler has compiled my index.ts, and I now have an index.js. So that's basically how it works, right? So we need to have that conversion for it to actually be understood by the browser. Yeah. So that's why we need the compiler. Okay, so moving forward. I don't know, any questions on the compiler? If you have any questions, like I said, stop me at any point. So we've seen a couple of points, a couple of types already in TypeScript, which are called the primitive types. So the primitive types are just types that exist in TypeScript, but technically they are also in JavaScript, but it's just that they are not called that way, or they are not explicitly typed that way. For example, if we say in JavaScript, coming back to JavaScript, if we decide to make name string by default let me get rid of this other code. If we make name string by default a string, meaning that if I hover over this, it's going to by default tell me that it is a var of name string, and it gives me actually the TypeScript type. Like VS Code is so good. And now if I decide to make it like 5,000, which is like a number, if I hover over it, it's going to tell me that, oh, name string is not a number, it's no longer a string. So these types are there, but they are not explicitly like, you have to come here and put number in JavaScript. This is wrong in JavaScript. You can only do this in TypeScript, but it doesn't mean that they are not there. So basically, we have some types that exist, but they are not like, they're just invisible types. They are there, but they are not there kind of. So we call that primitive types, and the types include things like string, number, boolean, null, undefined. And so when we want to use them in TypeScript explicitly, we need to come here and put like name with the colon, they'll put string, so that we know that the name is Alice and Alice is a string. Age, number, logged in boolean. So if it's a boolean, if it's true or false, right, you have to put boolean. Everything is in small letters. Don't mind that I actually use capital letters to the left here. Everything has to be in small letters. Then no means that nothing exists there. This is the issue that we had that caused us a lot of problems. It was null. So null means there's nothing there, and you have to explicitly have it like this. So it actually looks the same like the actual value, but it's technically not the same thing. Same thing with undefined. Undefined means that no value has been assigned to it, so it's basically not there, right? So it's undefined. So there's a little difference between null and undefined. They could be used interchangeably. In a lot of scenarios, they could be the same, but basically they mean two different things. So null means there's nothing there, while undefined means nothing has been assigned. But technically, there's still nothing there. So anyways, it's JavaScript. So yeah, we can move on. Yeah, special types. So special types are, where things get a little bit crazy. So I'm going to take this type step by step so I get to understand how they work, the gymnastics of everything, because it could get really weird at some point. Now, there are a lot of TypeScript developers who claim to be TypeScript developers, but they are writing JavaScript because they use a type called any. So with any, it basically means that a particular variable can use any data type, whether it's a string, a number. Most JavaScript variables, in fact, all JavaScript variables have the type any, right? For example, let me show you how this works. So if I come here and I decide to make like val, this is the JavaScript side of things. If I make it like 5,000, and I come here and I make name string like Tech Chantier, thank you very much, Tech Chantier. By the time I hover over this, it is a string. By the time I hover over this, it is a number. And if I say name string equals to, let's say, true, right? True. Now, by the time I hover over this, it's a boolean. This is supposed to be a boolean. Why is it showing me a string? That's very interesting. But this is a boolean. So you realize that this in JavaScript, like this works. If I have to run node index.js, it should actually give me everything should work perfectly well as it shows. But normally, this is not supposed to work in like TypeScript. For example, if in TypeScript, like even if I don't put this like a string, if I just make this a string like this, name string as it is, I think I should use the underscore so that we can get rid of this, this red line. So if I decide to come here and I say name string is a number, 1, 2, 3, 4, we're going to realize that it's going to show me an error because name string initially I've said that this is taking a string. So by default, this should be a string. So this cannot be a number. But now if I come and say name string is a Boolean as well, like, it's a Boolean, this is wrong because I've said name string is a string. How can it be a Boolean? But with the any type, I bypassed every rule that Typescript has ever made in its life. So if I come here and I decide to make like any here, realize that all the errors suddenly go away. Name string can be a string, it can be a number, it can be a Boolean, it can be a man, it can be a woman. So that's basically what the any does. It like tells you that you're using TypeScript, but you can still use like JavaScript and make everything any type. So, but you want to use this sparingly. I don't know, like the case where you actually have to use any. Maybe you're using another person's code, that is another person's code, and it's difficult for you to infer what that type is, then you can use that. But try as much as possible that if you should ever have any in your code, let the senior developer not see it because it's not good practice to have a lot of any's in your code, right? So yeah, so try to avoid any's, but if you have to use any's, this is how you use any's. So that's the any data type. Moving on to the next, we have unknown. If you have any question at any time, please let me know. The next type is unknown. So this is when you use something like you don't know what the data type is, or you just want to use it. It's very similar to any, but it's not the same thing. Yeah, but you have to be very wary when you're using unknown. You have to infer the type so that you're actually sure what type is it before you use it. So if you don't know what the data type is, you can use unknown. For example, looking at this example to the right here, this one here from let, you have let something equals to unknown. Let something unknown equals to world. So it means that it could be an integer, it could be a string. So when something's unknown, you usually want to check the type before you actually go about using it because you can do something wrong. For example, if this was a number, then you cannot do like something but uppercase because it's not uppercase of a number. So you have to make sure that unknown is very similar to any, but it's also very different as well. It's just like null and undefined. They could be used interchangeably, but they're not exactly the same thing. Yeah, please go ahead.
My question is, when we also talk of unknown, doesn't mean like unknown, it waits for us to first of all do our variable assignment. Once we have assigned a certain value to the variable now automatically takes that type, and that means later I cannot change the type. So is that what it means? Unlike any, which you can be constantly changing it. Thank you.
Okay, unknown is just like any. Well, let's say that scenario that you're actually talking about where we remove, let's just get rid of, if we get rid of unknown from here, then whatever this thing to the right hand side is, that's what something is going to be, right? So if this is a string, then something is going to be a string and it cannot be changed in TypeScript. You have to use only a string for something, right? But if you use unknown means that you don't know what this something is going to be. So it's almost like any, but just like null and undefined, they're not exactly the same. You can use them in completely different ways, but it just means that it could be a string, it could be a number, it could be, but it is unknown. I don't know if you get the point.
Yes, I get it. Thank you.
Okay, so let's look at an actual example where we have to use unknown. So if I replace this by unknown, for example, this works like flawlessly, just exactly like the any. So you could look at any to be the same like unknown, but it's just like not the same thing because any means any data type, unknown means you're not too sure of the data type. So it's more of the intent than the actual use case. So JavaScript could be confusing like that. And TypeScript could be, as confusing a little bit, but just know that there are not that many cases where there's this confusion. So most times, any and unknown can be used interchangeably, but they don't mean exactly the same thing. So it's just like null and undefined. So I don't know if that sorts things out. Okay, I hope it does. So we have void, right? So void is usually when we do with functions. So if you know JavaScript, then you should know that we can have something like this. Let me look at, first of all, the normal JavaScript way of writing functions where I can have, there are many ways, there are like 3 ways or 4 ways of writing functions where I can have like function, I can say print a number. Then I can be like console.log, whatever. Let's just be an empty, let's just be an empty function, right? So what I'm going to do is that I'm going to come here and console.log the print number, right? So I'm going to call it. So I'm hoping that you know actually what it means, what the function means, and what it means to actually call a function. So this is a function definition, meaning that this is actually the code that runs when the function is running. While for me to use the function, I need to be able to call it. It's called the function calling. I think it's a better word, but let's just call it calling. So I call the function like this when I want to use it, and it's basically going to give me the value. It's going to return the value that is returned, basically. So if I do a console.log here, meaning that whatever is returned here, which as we can see is an empty function, meaning that nothing is returned, is going to be printed here. So if I go ahead and I do node index.js, let's see whatever is returned. It shows undefined because undefined is returned. Okay. So what if we actually return something that is actually defined? But that thing was like void. I don't think there's void in normal JavaScript. But usually, if you don't return anything, it has to be void. I think for programming languages like C or C++, if you don't return anything, you're returning void. But by default in React, it is undefined. So this is where we actually see like an overlap, because we are going to realize that not returning anything could be undefined and it could also be void. So I'm going to show you guys how that works in a bit in TypeScript. But basically, if I don't return anything like this and I run this, it's going to show me undefined. If I leave this open as well, it's going to show me undefined as well. So if we have a similar function like this, let me just copy this because it's going to basically be the same thing. If I copy this and I paste this in our TypeScript side of things, first of all, it's showing me print number, is underlining because I have print number in the other file. So yeah, we have that fixed now. So if I now decide to be like, okay, I want to let's print this and see how it looks like. So we have tsc index.ts, and it shows us, what does it show us? Are we console login, print a number, what's wrong? Duplicate function implementation, y, number. Oh, I think that, okay, this was happening. So when I compile this, yeah, it overwrites that way and all of that. It's crazy. I'm going to show you guys how to fix this in a bit when you're doing like your actual work and all of that, but let's just forget about that for a bit. But now if I do like an index, if I try to run this, it shows nothing because nothing is actually printed. So normally if I have to come here and return something, let's see what other thing is printed as well. Nothing is printed. But now if I decide to put the void like this, by default, let me just, for a minute, let's get rid of that red there by change this back without the underscore. Now, if you realize, if I put void here, you notice that the void, first of all, there are two things you notice. The first thing that you notice is that I've come after the bracket and I've put void, and we realize that there's no error, meaning that this code should work flawlessly. Meaning that by default in JavaScript, if I return nothing, it returns undefined. But somehow undefined is similar to void. And I could also mean like write undefined here and I'll still have the code working perfectly. So this is still one of those scenarios where we have like overlapping types. So we have undefined used interchangeably with null, used interchangeably with void. So usually if I don't want to return anything in the function, I can simply come here and I put void. I can put undefined. However, I don't think I can put null. Because if I have to put null, it means I have to actually come and return null. So you realize you now see those places where actually the undefined and null are not exactly the same thing. But undefined and void in this case are actually very similar because they are used interchangeably. They are not exactly the same. I think no, they are actually the same. Void is the same. It's just that with undefined, it's both a value and a data type, while void is just a data type, void as it is. So basically that's how it works with void. So we've looked at the void data type and we realized that we can have a return of void if we are not returning anything in the function, and that should work perfectly well, or if we are actually returning, like, if we have undefined, it means we have to return undefined or nothing. But if we come here and we put undefined, I think we're going to have an error. No, void and undefined are actually the same thing. So yeah, so anytime that you want to return a function in TypeScript and that function doesn't return anything or it returns undefined, then try to use void here, or you come here and use undefined as well. So this is how we actually define the return types of a function. So while we are here, we can also do that for strings and numbers. So if you know that your function is going to return a number, then why not put number here? So number here, and you make sure that you return a number here, 5. So if by some error you forget to return the number here, as in you can actually come and put the number here, then TypeScript is going to tell you that, oh, you forgot to put the number that you said you were going to return. So that's where TypeScript actually has your back. So if I come and I put string and I'm returning a number, it's going to tell me, you can actually hover over it and it tells you type number is not assignable to type string, because what we were intending to assign to be returned in the function is a string and not a number. So you see where types are actually helping us to catch those errors that we can make by mistake, and very important for us to keep track of that. Yeah, so that is it about the void and how, and at the same time learn how to actually return, like show the return types when we're returning things in functions. So that's basically it. I know I've been talking for a while, so if you have any questions at this point, please feel free to let me know. Okay, so I might either be talking alone for the past 30 minutes or you guys actually heard me. I'll just bet on you. Okay, you guys heard me. Question, please.
Thank you, sir. Please, sir, my question is with respect to the type of the null and the undefined.
Yes.
So, if I'm supposed to, let's say the example that you just used, if I put the return type as, let me say, null, then does it mean I must indicate the null down here before the function is going to be executed?
Exactly. Because what null means that null means nothing has been provided, so it is null. The undefined means nothing is there. It's almost the same thing, but it's not the same thing, right?
Okay, sir. Thank you, sir.
On the word undefined, you can actually decide to put like nothing and it's going to work, right? You can either put undefined or you put nothing and it's going to be okay.
Okay, sir. Thank you, sir.
Yeah. Okay, so moving forward. So now we have never. So never is like something that never occurs, basically. So we're going to call, well, like, if you look at the various types, you realize that they are conflicting in terms of how they mean. Like never is similar to like null and undefined and void at the same time, but there's just this little difference between them. So for example, if you're writing a function that throws an error, errors will always return a never, because it's something that never occurs, because the function doesn't run because the error is being thrown. So whatever is supposed to be executed never occurs. So basically like that. So whenever you're dealing with functions that throw an error, for example, there's a function in JavaScript called a new error. So if I come here and I return a new error, and I hover over this data type, not error. So before I actually do that, let me create a variable, right? Let's create a variable called error, and we do a new error like this. And if I hover over error to find out what the type is, quick error is okay, returns an error. Okay, okay, let me add a true in front of it. New error. Why do we have a expression? I think it should be the spelling for true. It is the spelling for true. I think that true has the same, it has a similar function to return, so we cannot have like assigning that. But if we have to, let me get rid of this guy here. So if we come and hover over function print a number, so you see that it returns void, but also it could be never. So if I come here and I put never as well, this works as well. So you realize that there's also an overlap between void and never, right? But usually with void, you use it most of the time when you don't want to return anything. We never, you could probably be returning something like you're returning, like nothing is being returned here, like Python, right? Nothing is being returned here. That's why it's okay for you to put like undefined or put void, because nothing is returned. We don't have explicitly a return statement here. If you actually had a return statement, you're going to realize that the return statement is redundant, right? It's redundant basically because throw says the same function as return, right? So there's this little like overlap between never and void, because technically I'm not returning anything, so it's void. But since throw also like has the same function as like return, so it's also kind of also returning like never. So there's this little overlap in what they mean, and you just need to like with practice you're going to like master it and know how it works and all of that. But that's basically how we use it interchangeably. So you can, whenever you're returning an error or you're throwing an error, you want to use never. You can also use void because nothing is being returned as well. So that's basically it. So never, because it is throwing an error and the whatever is supposed to be executing never happens. But also void because there's no return statement, so it's returning nothing as well. So you can either use never or use void. I know it's getting quite confusing, but I really hope that you can get like the difference in how this works. So any questions so far? All right, so I'm assuming that there are no questions so far. Okay, so moving forward. I think I have to put my phone on do not disturb. Okay, so the next types of functions. Okay, and sorry for those distractions. So the next type of functions, the next type of types that we're going to look at are objects and functions. So we've seen like normal types where you have like never, just straight things like never, strings, numbers, and all of that, unknowns and any's. But now you can also have types to create your objects, right? Because this is something that you're going to be using a lot. You're going to be creating like objects with name, age, different, like for example, let's say we're building a tech shanty app where you can be able to like have like records of documents. Those documents are going to have things like names, you're going to have things like, you know, maybe dates and all of that. So you want to be able to put that in an object. So if you're from Java, they call that classes. There are classes in JavaScript as well, but you can also use like JSON objects as well. So let's look at how we can be able to create like the object type. So basically in JavaScript, I'm going to show how it works in JavaScript, and we're going to create a person object. So let's say we have a constant person which has by default a name, and this name is going to be John. Thank you very much. The age is going to be 30. We're not going to be dealing with admins here. We're going to be dealing with a human being. So let's say we're going to look at his legs, and we're going to have like 2 legs. We're going to look at his arms. We have 2 arms. Then we have like, what else can we look at? Another property. Let's say, is he is tall, right? So that we can have a Boolean here. Is tall, we can have true. Is rich, we can have false. This is a poor person. Sorry if your name is John on the call. But yeah, we can also have things like nested objects. So in JavaScript, you can have maybe like family members, and maybe we can have like Jane, Jack, Jill, and we can have like objects as well. So we can have friends, we can have like, let's say we have best friend is Jane, best friends with Jack and Jill. So basically, I'm just showing you like how much you can actually achieve with objects. You can have somebody, or you can represent an entity using properties. So we have what we call key value pairs, and you can be able to have like nested properties. Like this array itself could have like an object in it, so it could be that crazy, as deep as you want it to go. So basically, if you want to do something exactly like this in TypeScript, they wanted TypeScript to be able to know that a person must have a name and an age, number of these legs, arms, is tall, is rich. He's not going to have a tail, for example. So let's see how we can actually use TypeScript to be able to make our object very strict, right? So normally we have the normal way of doing it, which is like let person, uh, let me take this guy and just put here, just put this here, and yeah, we have that there. We have person. The reason why it keeps showing this red is because there's another file that has like exactly the same thing. So it just wants me to be careful. So we have name, we have age, we have legs, we have arms, we have install, it's reach. Just one sec. Let me tell this person that I'm on the call. Person keeps calling. Okay, so yeah, so coming back to this, so we have our normal object here, and this should work perfectly well. But I can decide to come here and put object as well. So if I want to like overkill it, I can come and put object here. But you should know that if I put string here, it should give me an error because this is not a string. So object is going to be like any object, this works. So this works if this is an object. So now if I decide that, okay, I want to make this like exactly the way I want it to be, then I'll have to like further define how this object is supposed to be. So let's say I didn't want to just give it object. I wanted to give it like, exactly how it should be. Maybe the name, I should have a name, that's a string. I should have an age, that is a number. I should have legs, which is a number, right? I should have a stall, which is a number, is rich, which is a number. And okay, so now because I have is rich, is stall a number and is rich a number, it's telling me that this cannot be true because stall here is true and is rich is false. So it should actually be a boolean. So it's actually saving me from making that very huge mistake. Okay, arms is missing, so it shows me that I don't have arms here. So arms should be a number. I know that this is going to be a bit confusing, but don't bother, I'm going to break it down for you. But now I just want you to see that if, let's say, for example, we have this structure already set out, and I decide to be like, okay, I want to be a creative creator and come and give a human being, a person, a tail, and I give it one tail, it's going to immediately tell me that in my definition of what a person should be, there is name. I see name, which is a string, age, which is a number, legs, which is a number, arms, which is a number, is store, which is a boolean, is which is a boolean, but I don't see tail. So if by any mistake I come somewhere else in my code and I decide to put a tail, then I'm in deep trouble. So you have to be, this is how objects actually help us a lot. So I must not definitely do the initialization and declaration installation at the same time. I can decide to come and put this after, and this should work as well. So I can decide to have my let person, and I put this, that, put the name and all of that, all of that. Then I come here and I decide to put that, okay, this is the object. So it mustn't be on the same line. That's what I'm trying to say. And you can also make it neater by putting this on like two different lines, like on separate lines, so it looks neater for your eyes to see, and so that you actually see how like it looks like that. So you realize that the difference between this type definition and the actual value which we are putting here is that the similarity is that it has the same like pairs, like the same pairs. Like we have name, we have age, we have legs, and all of that. We have name, age, legs here as well. But the difference now is that here is the type definition, meaning that what I have on the other end of things is going to be the type. String, number, boolean, boolean. And here I can actually put the values that match that type. So that is how objects work, the object type work. You can either put your own object here, you can put the generic object here, which should work, and you can decide to define your own object the way you want it so that it's stricter, right? It's still up to you, but that's basically how you can be able to type your objects in a nutshell. I'm going to show you a neater way to go about that using interfaces, but this is how you can actually do that, like real quickly. So I don't know if there are any questions so far. Okay, we have a question.
Good evening, sir.
Yeah.
So, so if, from what you said, it means that you can just define the object and all the properties that are found in the object with their data types. Then you are just, if you want to use, you are just calling it. If you are just using it down without defining again their data types, that would be a better way. That would be a better way now, from what you are saying.
Exactly. Without defining it,
Exactly. Without defining it,
yeah, without defining it,
Thank
you
you,
can
sir.
come here. For
yeah, without
example,
defining it, you can come here. For example,
so I can say if I come back here to the way it initially was, I can decide to put like create another instance of person, and because I've already created it before there, it already has like the format that person should have. It should have a name, it should have all of these things, right? So I can still come here and I change some values and all of that. But basically, you can decide to do like your definition and your declaration and your initialization differently. So putting your the types and all of the definitions and coming and using it after is still okay. It's just like you do, let's say for example, we do string here. This should be a string. So I know that whenever I'm using this variable, I must use a string, and that works. So it's basically the same thing, but now with objects. I don't know if that makes sense or if that answers your question.
or if that answers your question.
Yes, sir. Yes, sir. Thank you, sir. Awesome.
Okay. Any questions? Any other questions? Okay, so I presume no other questions. Okay, so we've looked at object types. I really hope that we can be able to go further to revisit all of the types. If not, then I'm going to show you some examples on the types because I'm looking at the clock and time seems to be passing by really quickly. So let's look at arrays as well. So we've looked at, how you can be able to easily just, create your person, right? What about arrays? So arrays are just like chains of things together in a way that you can easily iterate through them. So let's call this an array of like uh what can we call it? Fruits, right? Array of fruits. So it means we can have this is the JavaScript side of things, right? We can have a mango, we can have so let me just in line with what we just spoke about, let's try to like separate the declaration from actually initializing it. So we'll have that there, right? We have that. So this is actually an any because it could have anything. There's no type attached to it. So maybe if I came here and I put like this, it's going to tell me that it's an any array, right? But for now, I'm just going to let that lie so that I can have some little bit of structure and show you guys how things work. But now we have our fruits. Let's have oranges inside. Let's try to be creative and salivate a little bit. We have papaya. That's what papaya is. It's pear. We have pineapple. Thank you very much. Okay, so we have fruits and we have that. So what if I just came here and I decided to put maybe a 9? Now there's no way that I'm going to be able to know if I've made a mistake or not. Let's say, for example, this was a typo. I just by mistakenly put 9 and I'm going there and I'm typing and I'm typing and typing and I'm getting to the code, all the algorithms and everything, and I forget that I actually made a mistake and I put a 9. So there's no way that I can actually come and tell JavaScript that JavaScript, please make sure that everything here is a string. It's really hard. Even if I come here in the beginning and I decide to put initialize this with a string so that I know that, so TypeScript will tell me that this is a string array, like JavaScript knows that this is a string array. I can still come here and put like another, like an array, then put a number, and TypeScript is going to be like, oh, you changed the value. So this is no longer a string array, but it still works. But like basically JavaScript cannot really help me to catch that error. That's what I'm trying to say. But what if we had like, TypeScript, which we have? We can basically just have the same thing here. Let's get rid of this person. And it's going to tell me like, what's the error? Cannot redeclare block scope. The issue with redeclaring stuff. So we have to just put our underscore here so that we don't have a conflict. All right, so what's it saying? The fruits is any because I didn't give it a value initially. But let's say, for example, we wanted to make it stricter. We can either decide to come here and put like a string followed by a bracket for string array. So string array means that it's going to be an array. First of all, these two square brackets here meaning that it's an array. But now all the values inside are going to be string. So it means that if my compiler should go through and be like, okay, mango is a string, orange is a string, papaya is a string, pineapple is a string, 9 is not a string. So it means that we have an issue here. Now, but what if string was actually an, sorry, not integer, a number array? Now it's going to be like, mango is not a number, oranges is not a number, papaya is not a number, pineapple is not, 9 is a number. So basically, using arrays, you can actually use an array and tell TypeScript that this is how I want my array to go. If I make a mistake, tell me that this is not how it was supposed to be. So that's how we can actually have like arrays. Use TypeScript to be able to check arrays. Now there are so many things you can do. You can add whatever data type you want to do, all the primitive data types. If you want it to be an undefined array, you can do that. And everything here, since it's not undefined, is going to throw an error. If you want it to be a null array, then everything here is going to be, still wrong. But now, what if you wanted the first element to be a string? Sorry, I have to always put the type in front here. If not, it's not going to work. So let me just put string array here so that we have our issue at 9 here. So what if you wanted the first element to be a string, the second element to be a number, the third element to be a string, the fourth element to be a number? So what if you wanted a mixed array like that? So there are two ways you can go about it. The easiest way you can do it is you put your brackets around this so that you can enclose it just like BODMAS. And you put, we're going to get to this in a short while, so don't be overwhelmed. Don't bother if you don't get this, we're going to get more in depth in a few minutes. But you can put this in brackets. This in brackets still means string array. But now when you put a strong, like a straight line, I forgot what that means. I don't know what that means. That's a slash, a vertical slash, really straight slash. You can add a forward slash, backward slash. I don't know what the slash is called, but it's just one straight line. And you decide to put number here. What this means is that I have an array which could either have a string or a number. Now, don't mistake this for actually the double this, which actually means or when you're dealing with the actual values. It's actually a single slash. So make sure that you have a single slash, not a double slash. This just means that this could actually be a string or a number. But what if I wanted it to be so strict that I wanted the first one to be a number and everything else should be a string? So what I could do is that I could be more specific and say that, okay, I have 4 elements in my array. One is a number, the other one is a string, the other one that follows is a string, and the other one that follows is a string. And now this works. So by putting these square brackets and putting the actual values inside and saying that this should be a number, this should be a string, it means that if I by mistakenly take one, which is supposed to be the first one as a number, and I put it here, it's going to show me an error because this is supposed to be a number and it's a string. It's supposed to be a string and it's a number. So Typescript is going to be like, oh boy, there's an error here. Please check it out. So yeah, you have to be, know how to interchange things and like that so that you get to, make your code more intelligent. So you have literally like an AI in your code that is telling you like, you said this, so why are you not going against your word? Why are you going against your word and all of that? So that's basically it, not to waste too much time here. And I've showed you 2 ways of actually typing 3 ways of typing your arrays. The normal way where you have your string array like this, or your integer array where you must have all strings or all integers or all booleans. And I've showed you the other way where you can be able to have either a string or a number. Sorry about that. Or a number. You can have multiple types. So you can have a string or a number, or a string or a boolean. Right? So it means if I have a boolean here like true, it's also true. I can also decide to be I want a string, a boolean, or a number where I can now add another dash and I put a number. So it's going to be this could either be a string, a boolean, a number, and so on and so on. It all depends on how many different things you want to have. So anything that is contrary to that, for example, if I come and I put undefined here, which is not one of the types that I'm expecting, then it's going to throw an error. So that's the second way I've told you how to actually type your arrays. The third way is if you have a specific structure in mind. So if you want you want number, right? You want a number, then you want a string, right? Then you want another string, right? Then you want you want like a string, then you want like a boolean, then you want like undefined at the end, then yeah, you can have it like that, and that works. So if I by mistakenly interchange any one of these, then we should run into some serious issues, right? Yeah, it's no longer correct, so we run into some issues. So that's basically how we can be able to type our arrays. Yeah. Yeah. Any questions so far on typing your arrays? Okay, I assume that there are no questions. Moving forward. Function types. Okay, so function types, I think that we've seen a little bit about function types. The one thing I want to point out is that a function, let's look at JavaScript, right? Always start with JavaScript so that we see the difference. A function has a couple of parts. It has the function name. It has the function parameters, for example, A and B, and it has whatever is returned. So returning 0, for example, in this case, or we can do return A plus B. So let's just say return 0. So we have the first part, which is like the function name. We have the function parameters or arguments. So whatever you want to call it, parameters or arguments. And we have like, what time is it? Okay. We have like whatever is returning. So the function return or the return value. We can call it return value. So the things that we can actually be able to type are the parameters and the return values. And you can actually be able to do types like that in TypeScript. So now I want to show you like where there could be actually a potential mistake or error that you make when you actually don't type. So a problem that if you use just JavaScript, you face. So let's say we have A plus B, right? A plus B. Let's use A times B. Yeah, A times B sounds like a disaster. Okay, so I'm going to tell you in a bit why that is a disaster. Because if I decide to say, okay, let result equals to me calling the function by its name, 2 and 3, right? 2 and 3 is a number, so if I consider the log result, it should give me whatever A times B, which is 2 times 3 is. So we should be expecting a 6. So if I come to my console, let's clear it so that we don't have all these repeated things here. And I use note index.js. Fine, we have 6. Everything is good. Everybody's happy. But let me actually put text shanty here. And let's see what happens. So inside the code, we're going to see 2 times text shanty. I don't know what this is going to happen. I don't know what's going to happen here, but I think that my computer may freeze. So if I'm not talking for like, the next 1 hour, I know that my computer is probably shut down or something. I'm kidding, but let's just see what happens. So if I do like a node and index.js, not the number. So any n means not the number. So whenever I'm trying to compute something and the result is not a number, then it's going to tell me n. I think that if I was using something like assembly language to write this, my computer would have actually legitimately crashed. But because JavaScript has actually tried to look at this and try to avoid your computer crashing from all of these issues, it actually provides a certain, not a number value that tells you that whatever the result is not a number. So you should forget about thinking whatever it would have been. So yeah, so this is actually one of the potential issues that you face or you run into if you actually don't know what you're doing. So you have to make sure that you're using your types that are going to warn you beforehand that you're trying to do a computation that will lead to something that is not correct. So how do we fix this in TypeScript? So we are going to copy exactly the same thing in TypeScript. Then we're going to see how we can be able to fix it in TypeScript. So I'm going to get rid of this time. So we're going to come to the source code and get rid of that so that we can actually use our function name in peace because it's not repeating. Okay, so this is how it looks like in TypeScript. And what I'm going to do is that first I'm going to type the A, then type the B. You can have as many parameters as possible, but since we're dealing with this example, we're going to type this too. And optionally, you should be able to type the return type. You mustn't type it, the return type, all the time. It's not really compulsory. It's not neither is compulsory when you're typing the parameter or your return type, but it's just best practice because it gives you a safety net in case you make an issue or you make an error somehow and you don't return the right thing you're supposed to return. So to come into the parameters, if you want to be able to type the parameters, it's very simple, just like we did for the other ones. We add a colon and we put the parameter type, right? Column parameter type. So A is going to be expecting a number, and B is going to be expecting a number. So guess what happens here? Function name 2, which is A, and B, which is supposed to be a number, but a string is now showing an error. So TypeScript has successfully helped us to figure out what our computer could potentially have gone through if we did not see this. It's just like when your mother tells you that don't marry that girl, but you still go and marry the girl. So it's like that. What a woman sees sitting down, the young couple cannot see standing on the Iroko. I don't know whether that is it, but you get the point. So we've been able to address that. We have the A number and we have the B number, and we can be able to call the function, and if this is not correct, then TypeScript tells us that, bro, you're going to marry the wrong person, so you should have the right person. So if you should marry a Bayagi girl or a Bakri girl. So basically, that's TypeScript's own version. Now, what if we wanted to actually tell TypeScript that I want you to return a specific kind of value? And we've seen that before where we're able to return a void here. Then we're going to quickly realize that because A is a number and B is a number, whatever A times B will be is going to be a number. So if we hover over it, it's going to tell us that type number is not assignable to type void, because by inference, if I multiply a number by a number, I should get a number. So me saying that I should return a void is a mistake. So I should come here and put number, right? And what if I decide to come here and I say A times B dot to string? So this is me converting it to a string. It's going to be like, oh, you say you're going to return a number. Yes, A times B is a number, but you've converted it to a string. So this is no longer a string. String is not assignable to type number, as you can see here. So if I hover over this, it's going to be like type string is not assignable to number. So whatever I am putting here has to match whatever I'm returning, wherever I'm returning it. So it's just good to have these types as your safety net so that you don't get to fall into issues or run into mistakes or put the wrong type where the right type is supposed to be. You get the point. So your variable should not be at the wrong place at the wrong time or at the wrong type. Get the point. All right. So I don't know if there are any questions so far. You want me to address something you have a problem with, like how you can be able to type your parameters or your return values. This is the time you can ask me now. Okay, so assuming that there are no questions, we can move forward. So this is just like watching a YouTube video and the person just going and going and going. The only difference is that I can actually ask you, like, do you have a question? But usually, with all skills, you really learn by practicing. You don't learn by getting this knowledge. This knowledge easily flees. So I'll advise you that when you go back, you get this PowerPoint presentation or this PDF, and you actually go and start practicing by yourself. Look at the examples we've done. There's a recording, so I think that you can actually follow the recording to look at what we've done so far and try to do it yourself, right? You only get the skills by muscle memory. Yeah. So moving on to unions and intersections. This is something that I've seen before, but we're not seeing it like that. We saw it in arrays, but you're going to see this better, when I explain it here. So unions is like what we used to learn in arithmetic or mathematics back in primary school. So union means that two things can actually coexist together, right? So I can have a string and a number coexisting. Intersection means that you're more like combining two things together, like that thing in the middle. So I can have an intersection of this and this person to make this person. Somehow they are almost the same, but the difference with union is that they cannot coexist. With intersection, there's a coexistence. You're going to see that, like, I'm not using the right words, I may not be using the right words, but you're going to get with the examples. But with the union, two things can exist, but not at the same time. But intersections, two things can exist even at the same time. So that's basically what it means. So let's see how unions work. And we've seen that when we're dealing with arrays, having a string array and a number array at the same time. But now we're going to look at a number. So we can say we can have a variable called what can we call it? Maybe the name of a company. Let's call it company, right? So let's say a company is called let's call it let's make it more fun. Let's say prisoner, right? So a prisoner can either be Samuel, right? was it? No, let's call it Joseph. Let's be fair. I don't want to be attacked. Joseph was actually a prisoner in my defense. So we can say Joseph, and maybe we can decide that, okay, in another instance, we want to say prisoner is prisoner 105 because some of these prisons, they actually use their numbers. So basically, we want to have the prisoner existing as a name and also as a number. So what we can do is that we can use number, right? And we can also use, the slash. That I don't know whether it's vertical or horizontal, but it's vertical. But I don't. There's a forward slash, a backslash, but this is straight slash. Let's just call it straight slash. So straight slash, and it's either a number or a string. So what this means is that Joseph, the prisoner, could be Joseph the string or the number 105, and we have the two values coexisting, but not coexisting at the same time. However, intersections are a bit different. So I'm just going to, have a line here, and I'm going to come down here for intersections, or how intersections work. So we have intersections. So with intersections, let's have I know I've not spoken about types, but if we have a type person, we realize that there are two ways that you can be able to create your generic types. You can actually just put the type as it is here, or you actually call the type, or you can use an interface, but the structure is a bit different. But let's look more into interfaces in a bit, but just play along. So we have a type called person, and we have a type called employee, as we can see here. So person has a name and an age. We have employee having a name, age, number, and salary. So it means that somebody who is an employee here should have what the person has and what this other person has. But let me get rid of this name and age, because there's this is appearing in both person and employee. So now with intersection, we have two things coexisting, but now at the same time. So it means that if employee has the type of a person and the type of an employee, then it means that employee should be able to have a name. So let's say employee is Chris, and employee is also having an age, which is, sorry about that, age, which is 15, and employee should be able to also have a salary. So basically, we have two types. If we did this, this will not work. This should not work. I don't know why it works, honestly. But this should not work because with person and employee, there should not be any coexistence. This is a union. Two things should not really coexist at the same time. This works, but this is not really best practice. You should be able to use this when you're person or employee. But because person and employee don't have the same age, I have no idea why this is working. But basically, this is how you should use it. This is the right way to go about it. You use the and, because you're dealing with an intersection where you have all the properties in person and you have all the properties in employee together. So you have name, age, and salary. But if you have to use this, then you should either be having whatever the employee has, whatever the person has, which is either name or age, then, or you should either have just what the employee has, which is salary. So if I can have salary here, and this should be 1,000, and that should be fine as well. So basically that. So I can either have name, or I can have name or age, or I can have salary, or I can have but not the two of them at the same time. If the two of them at the same time, then the correct syntax should be the and, right, not the straight line. So basically that. So yeah, any questions so far on intersections and unions? I think that there's a little bit of confusion there because of the fact that we can have an intersection having the possibility to act as a union, but it should not be the case. You should have the syntaxes separate, the same thing. So if there are any questions so far, then I can be able to take them. But if not, I should just move forward. Any questions? Okay. All right. So we've seen that example. Let's see enums, right? Enums. Okay. So let's say Mr. Martin is in my class, there are only going to be 5 students, and that student is going to be either Martha or Jude or John or Joseph. there's one other student, Seraphine, for example. And if any other student comes into this class, it is a taboo, it's a restriction. We have to beat that person up. Now we need to have like some way of checking to make sure that we only have those values being shown up. So this is where enums come in. So with an enum, if you look at the syntax, you have to always start with an enum followed by the name. Then you have some values as you can see here. So you can see these values as in these are the only things I'm expected to see. Anything other than this is not supposed to be here. So we're going to create an enum for students in Mr. Martin's class. So students, and I didn't see everybody's name on the call. So if you don't see your name here, it doesn't mean that you're going to be evicted. So just to put that out there. I think I saw Ferdinand, he was the first person to talk. Then I saw Princely, was the person that was disturbing me with the mic and everything. Then I think I saw like, I don't know if it was Peter, or Frank, or John, or Smith. But these are the students in the class. So if I want to be able to say, okay, a new student comes in, a random student, and I come and say, okay, console.log, I want to console.log this random student, not console.log, but I want to verify the type of this random student, and I say, students dot, let's say, who is not here, James is not here. I should immediately get an error because, first of all, James is not in the class. And the reason why James is not in the class is because our enum is specifying a certain number, some certain values that need to be there. And if they are not there, then it should tell me and it should give me an error. So as you can see, I've already given a use case where you can use enums. Use enums where you have specific values that you don't want to be changed, right? Like Ferdinand, like Prince, like Peter. And if there's something else that is not there, then it should signify to you that like you made a mistake and this should be something else and all of that. But that's basically how it works. And another thing that you can do if you are very good with JavaScript already is that you can be able to destructure the values in an enum and use the values as they are. So I can be able to use just Ferdinand and come and say that, okay, let's use just Ferdinand. Ferdinand is a student, and we can probably give him like a value and everything like that. But enums, you want to use enums when you have specific values that you don't want to be changed and you just want them to be exactly the way they are. So yeah. Any questions on how to use enums? Any questions? And yeah, if I come and put James here, it's good. It's going to show an error. So this is just another way of doing it. You can destructure it like this, or you just basically have it as it is here. Yeah, question, please go ahead.
Thank you, sir. So please, I wish to ask for the enum. Is it also like a data type, or is there or can you give me a specific case where it can be useful?
Okay, so I can have it like this, like a value, right? It could be a data type, it could be a value, it depends on how you want to use it, right? So you can be able to console.log this. Let's console.log this and see how what it shows us. If I console.log Ferdinand, so it's more like a data. It's more of a data type, right? Yes, it's more like a data type. So it's more of these times where you can have like undefined. So if I come here and I say enum and I put another value here, so like Ferdinand, it throws an error and everything. But it's more like a data type, meaning that if let's console.log students, for example, let's console.log students and console.log Ferdinand and see what shows up there. So if I come and I do tsc index dot ts, let's see, okay, it shows nothing because it's actually acting, it's more of like a type check for types. So if I want to be able to have like certain, why am I having some issues here? Enum declaration only merge with namespace or enum declaration stands for totally declared. Okay, give me a second. Let me get rid of this, guys. Okay. Enum must only also be declared. I don't know why. Okay, that's because I ran it and we're having this issue with the, sorry about that, with the whole mix-up and the compiler. But basically, it's just for type check, using mostly for type check. So if you're doing something like, I'm going to tell you guys about interfaces in a bit, but if you're doing something that has like strict, okay, let me give you an example. Let's say I wanted to create a data type, for example, like let's say const let's say name. Let's say name. I can say the name is underscore student dot Ferdinand. Then I give it like a value. So the name is not assigned to type student dot Ferdinand. Okay. Let's say the name is student, right? I'm having a little mix up here. Students. This is not the right example. I'm trying to look up for an example where I can actually show you how you can use this enums. But yeah, I'm really thinking hard for an example that I cannot really find. But I think that for what I'm trying to do here, I'm trying to show you like a particular data type where you can actually have like specific set of values, and usually that is going to actually work well when you're dealing with interfaces. I'm going to tell you guys like maybe we'll talk about interfaces for this particular use case, but I'm looking for another use case where we can use enums as actual values, but it's not really applicable like that, using mostly for types. Where you can actually use like actual values where you actually restrict some certain values is where you're dealing with interfaces. I'm going to show you how that works like in a bit, but for enums, you're going to use them just exactly as they are. So like, just like we have like students dot Ferdinand. This exactly how you're going to use it, so that you're just using it as they are. But if you want to like restrict like some data type, let's say for example you have an object. Let's say you have like let's call these objects, and you have like names, and you want the name to either be Ferdinand or you want it to be something something something. So if you want like if you have another name that's contrary to this and you wanted to throw an error, I'm going to show you how to do this more with like interfaces. But if you have to use enums, you have to use enums as they are. So students of Ferdinand, students of Princely, and all of that. But if you want to use that to actually restrict the type of a particular type, then you have to use more like interfaces for that. Yeah, so I don't really use enums a lot because there's that really restriction how much you can use it, but you're going to see more of the usage of using like multiple strict values for elements more when you're dealing with interfaces. I'm going to show you how that works in a bit, but this how you basically use enums to actually show that okay, a particular enum is supposed to have just this set of values and nothing more. For specific values, I'm going to show you how to use that with interfaces. But yeah, that's how you can use enums.
Okay, thank you, sir.
Okay, so all right, so I think that the next is actually interfaces. We've seen how we can be able to create like strings and numbers using, so this is a type, using the type. So we just saw types shortly when we were dealing with employees and person. We're going to see types again, and we're going to see it.
So,
Yes. Go ahead, please. Hello? Hello? Okay, so moving forward, so we've seen types when we're dealing with the person and employee thing, but we're going to see how we can be able to work with types and also interfaces, and talk about how we can actually use what I was trying to do with enums, but with interfaces, since it's more applicable with interfaces. So if you want to be able to define your own type, maybe you want to define a tech chantier employee, or sorry, a tech chantier student, what a tech chantier student should be like. Then you can use a type like this, and you give the name of the type, let's say tech chantier students. So you're defining your own type, you can give it your name, whatever. Then you basically come here and you put like, it should be a name, it should have a name, which is string, age, and maybe you should pay fees.
network.
So pay your fees, which is a number. Okay, probably network. So probably you should pay your fees and all of that. So if I come here and I decide to create another object, maybe I can say let a particular student, let's say student 1, which is a tech chantier student. His name is going to be Ferdinand, his age is going to be 22, and he's going to pay 100,000 for his school fees. So I think that a better word for pay should be fee, right? So we have fee. So basically, this is a tech chantier student. But if I decide to get rid of one variable, it's going to be like, no, a tech chantier student must pay fees. So we realize that we have a fee here, right? So tech chantier must have fee. So you can decide to have your own data type. You can decide to have your type. You just put your type. You put the type. This type is actually something that has to be fixed. It's they call it. I've forgotten the word they give to it, but they're just these connotations that are fixed and you don't have to change them. Then you have like the name of your type, whatever you want to give it. If you want to give it Ferdinand or you want to give it whatever, it's up to you. Then you come here and you actually give out your types, like name, age, fee. Now, coming back to what I wanted to show you guys, what if I wanted the names of these people to either be Ferdinand or Mercy, right? Ferdinand or Mercy, right? So if I by mistakenly come here, let me put my fee. The person has to comply and pay their fees of 10,000 francs. So what if I come here and I put Prince? It's going to throw me an error because based on this, based on what I've defined here, it's going to be either Ferdinand or Mercy, but nothing else. So that's where enums actually have power. Like in multiple different programming languages, you see enums a lot. But in JavaScript and Typescript, it's just a little bit different. So if you want to actually achieve the same thing using your types, you can actually use this. Instead of putting just string, you can put the actual value here that you want it to be strict to. Now you can use an or if you want to have like multiple value checks. So that if none of this actually matches, it's going to be like, no, Prince is not part of this, and this Prince is not part of the class. Prince does not comply to be part of Tech Shanty team or Tech Shanty students. So that's how you can actually be strict on whatever these values are. So you can use this in multiple places, even as a variable itself. So if I have to come here as a variable and I say const name of person, and I say this person has to either be Peter or Paul. So if by any mistake and I come and I put Joseph here, it's going to tell me that this is not correct because it's expecting Peter or Paul. So that works. So you realize that you can use this to check exactly what you're looking for and find it. So this is one way for you to create types. So I've looked at using the type. The other very, very popular way among TypeScript developers is using interfaces. Now, the difference is not too much because you actually can use them interchangeably, but the huge difference you're going to realize is in its syntax. So for us to be able to create a similar something here, but let's call this interface. So basically it starts the same. So you're like, oh, it's practically just the same thing. So you can have Tech Chantier and interface, and you could have like, instead of you having like the equal to, you ditch the equal to, and like too long. And you must have an interface. The reason why I'm adding an interface because it's the same name and it's going to throw an error. But what if I change this to be like Bootcamper or Bootcamp, right? And instead of you putting like the equal sign, you can actually come here and put like this, and you can put the name. You can say the name should be like, same thing like you have there. You can have the name, which is a string. You can also have like just string here if you want to leave it that simply. You can also have like the age, which is like number, the fee, which is like a number. So it's basically the same thing. It has the same function, but it's different in a couple of ways. The first way is the syntax. The second way, which you're going to see as you go deeper, is that you can have things like inheritance with interfaces. You can inherit an interface, you can extend. It's called extend. So inheritance, just like if you're from an object-oriented programming background, you know what inheritance means. So you can be able to do that with that. So it's basically the same thing. So I can come here and I give like, let A equals to, or let A Tech Shanty Bootcamp be equal to that, and I can be able to give like initialize the value here and all of that. So this is basically saying that, oh, I don't like string is too lame, number is too lame. I want to create my own data type using the existing primitive data types. So building on what already exists to create your own data types. So that's basically how you can be able to use types and interfaces to create your own data types. Yeah. So I don't know if there are any questions so far. Any questions? Okay, go ahead, please.
Thank you, sir. So I think I'm a bit confused between the type and the interface at the level of the differences.
to ask you. Okay, let's start with who is the person who asked first? That was Rodrigue.
Kingsley, sir.
Yeah, who is the
Kingsley,
person
sir.
who asked? Okay, Kingsley, let me answer you first. Okay, so the first obvious difference is the fact that with the type, with the type, you have like the type, then you have like an equal to, then you have like, the syntax is different. Then here you have just interface and this. Yeah, that's the first obvious thing. But one thing I didn't really want to go deeper into because of time is that you can be able to extend an interface. So let's say you have a Tech Shanty bootcamp and you have like interface bootcamp, right? Let's actually change some things. Let's use bootcamp as it is. So let's say a bootcamp should have a hall where the bootcamp is supposed to be, which is a string. Let me use a real example. It should have students, and the students should be like Tech Shanty array. Thank you very much, because it's actually these people being an array. I hope you don't get mixed up. In case you get mixed up, let me use a string so that you know that issue. Like, it's something that you're already versed with, so I don't increase the confusion. So a normal bootcamp should have a hall and students. That's what the normal bootcamp should be. But now with interfaces, what you can do is that you can extend another interface. So you can come and say extends an interface. So this is just one of the things you can do that makes it like superior to types. So you can extend an interface and be like, okay, a bootcamp, a Tech Shanty bootcamp, what is unique about a Tech Shanty bootcamp? It should be organized in, let's say, the location should be Boya, for example, or let's just say it should have a location. Let's look for a different, like a better example instead of location. Let's say it should have tutors, right? Let's say this is one of the, it should have tutors, and let's say the tutor should be a string array, and it should have, let's add one more thing. It should be online. So online should be Boolean, right?
Excuse me,
Boolean.
sir. The presentation is freezing. We cannot see what you're doing, sir.
Is everybody having the same issue? Mr. Martin, are you having the same issue?
Sorry, what was that? I did not hear you.
Is the presentation freezing? Are you seeing what I'm showing?
Yes, I am seeing your cursor is blinking. It's on line 18.
So it's
Has it
clear
moved to
now.
line-
It's clear now.
Okay, I think it's clear now from what they say.
Okay, cool. All right, so we realized that we have some extra functionalities that are available to interfaces like extending, you being able to inherit. So basically, a Tech Shanty bootcamp extends a bootcamp, meaning that a Tech Shanty bootcamp should have everything that a bootcamp has, plus it should have tutors, and it should either be online or not be offline, so the Boolean. So we have like these extra things that come interfaces that make it superior to just types. So that's like, these are like the differences that are between like types and interfaces. Yeah. I don't know if that makes sense now.
Yes, sir. Thank you, sir. It's clearer.
Okay, great. As you go deeper into TypeScript, it's going to make more sense. You're going to see more examples. You're going to realize that types are also technically a JavaScript thing. So there's a way that I can actually compare your types in JavaScript. So as you go deeper, I don't want to go too deep because it's a beginner's course. I don't want to increase the confusion. But if you go deeper, you're going to realize that there are more differences, and you can decide to pick whether you're using a type or an interface depending on the scenario and the situation. But I encourage you to do more research on that. Okay. Moving forward. Okay, so we've been able to go through everything, the various types and interfaces, and integer numbers, strings, enums. We've seen how you can be able to use intersections, unions. We've been confused a few times. Yeah, we've seen a couple of examples as well. So this the last part of the presentation is just going over something, a little program that has everything combined, hopefully everything combined, because I'm actually looking at that off the top of my head and trying to come up with an example that is going to make sense and has everything that was spoken about. And if you guys have any questions after that, we can discuss them. If not, we can close the session. But hopefully hope that was an impactful one, and we had to learn a few things and get confused a few times. So yeah. So let's think about the scenario where we have to build this very huge mobile application for Google, and they're like, we think that the Tech Shanty campus can be able to do this. So we're going to give you guys a task to build YouTube. And they're like, okay, I want you push to be able to do a couple of cool things, and I want you guys to be able to use TypeScript and build something that is really wonderful. So basically, our React Native developers who have learned TypeScript, we're not going to be doing any UI stuff, but we're going to find a way to emulate how the YouTube platform works. So we're going to make it very simple. Obviously, we're not building YouTube. I'm just trying to give you guys like a backstory so that it seems fun. Okay, so we're going to start with like YouTube videos. If we're looking at the landing page, we know that YouTube videos should be like an array. So let's say we create an interface called YouTube video, right? And remember that an interface is a way that we can be able to create our own types. You can decide to use the type, or you can decide to use the interface. So a YouTube video should have the title, right? It should have the title, it should have the author, it should have views, it should have likes. It should also have like a thumbnail, right? That's what you see when you go to YouTube, right? It should have like the URL itself, what is playing behind the scenes. So it should be a string. Now, we should also have comments, right? Now, this is where things get tricky. So you could have comments as a string, but what if you wanted like in-depth comments? So we'll put a pin on that, on the comments thing, and we're going to come back and see how we can make it a lot better. So we have YouTube videos. In that same platform, we're also going to have users. So we have a user, which is an interface, and that user is going to have a name, is going to have the age, the email, the password, and his videos, like, his YouTube videos. And I want you to realize that it actually takes what we've created up here, YouTube video, and it adds the array behind it, meaning that what he's going to have is going to not be a string array, but it's going to be an array of YouTube videos. So you realize that we have like interfaces that are using other interfaces, or types that are using other types, and it's just making the thing all fun. So we have YouTube videos. Exactly. I really wish that I could show you how this works with React, but unfortunately I don't have a React application, bare React application working. I could probably show you like code, but it could really be a lot of code and it could confuse you. So I'll just stick with this. And finally, we have the user, the YouTube video will create a very, very minimalistic, view of how things should be. And what else do we have? We have what other entities could possibly be here? We have recommended videos. So we have interface recommended. Now, recommended videos, we could literally copy everything that is in YouTube videos because also a video, right? Recommended video. And under here, we can come and put like the rating, right? Or the rank. Let's call it the rank. So let's say everything has a rank, which is a number from, let's say, 1 to 100. And if you're 100, means that you're top recommended. If you're like 1, you're like least recommended. Let's just assume that. But now, to make this easier for us, we are going to inherit from the YouTube video type, and we'll get rid of all of this, because just by adding one line of code saying extends YouTube video, we have taken everything that YouTube video has and just added like rank number below. Life is good. So basically what we're going to do is that we're going to write a function called recommend. So function recommend. So coming back to what we learned, when we're recommending a YouTube video, we need the user because we're recommending based on the user. So we're going to pass in the user here, and the user needs to have the user type. If not, we're not going to know what the user means, right? So we have to pass in the user type. If not, it's going to take by default the type any. And we want to return the recommended video, right? So once we return the recommended video, everything seems good and nice. Okay, so but now we're not returning anything, so it's telling us that recommended video is nah. So what we want to do is that we want to just do something real quickly. I think that you guys know what for loops are. So we're going to use a for loop that starts from I equals 0 to I less than, not the user's videos, but we also need all the videos. So we need two parameters. We need the user and we need all the videos are on the platform. We're just doing some very funny looking algorithm here. This is not the YouTube algorithm. Please don't write this in any YouTube examination, or if you're going to apply for an interview in YouTube and tell them that I'm the one that project, not tell you anything. So we have like videos, the length. This is going to be a very cumbersome algorithm. I'm going to be like, if so let's have a variable here called const, and this const number is going to make sense at the end. We're going to have recommended videos, and this is going to be a recommended video array. By default is empty. So we're going to say if the videos dot author, for example, let's say is let's say videos on match, right? Let's say user the video don't match, the videos don't match. Okay, let's say match is a map. Okay, let's say filter. Let's use a filter. So this is going to make it a bit weird because I don't think I'm going to need the for loop. So I'm just going to simply go in. So let's use this. Let's use a let, because const is going to make me not to use that. So I'm going to say recommended videos equals to user dot videos dot filter. I'm going to be like, okay, if the video, which is a YouTube video, I don't know if you guys have used filter before, but don't worry, I'm going to explain what I'm doing in a bit. So I'm going to be like, if the video dot author equals to username, very bad algorithm, then we're going to return this. So what am I returning? I'm going to return true. So what I'm returning here is a YouTube video, but what I'm expecting is a recommended video. So what I'm going to do is that I'm going to still do a map here, and we're going to have a video here. This is a very spaghetti algorithm. Let's stay with me for a bit, and I'm going to say we have the video, and we have what do we have? Rank, mad or random, and then we're going to just return the recommended video. Okay, so we have our very powerful YouTube algorithm that didn't actually use the actual videos that we want to use from YouTube. So this is very absurd. But anyways, I wanted to show you guys a few things. The very first thing is that whatever I have to return here has to be a recommended video. So let's say I didn't do this map here, we're going to run into an error, because what we are doing here is that we are going through the user array, we are getting the videos he has watched, we are filtering through, and the filter is just a function that takes another function as a parameter and returns a true or false, and it's going to return a value like some arrays depending on what the value is true or false. I think you can do some more research on that. But basically, I'm going to get some return values here on if, depending on if the video's author is the username. If it's not the username, then we're going to assume that it is a recommended video. But now we're going to realize that since the videos that are being sent to this array are exactly a YouTube video, it's not recommended, then this is going to tell me that, oh, I'm actually expecting a recommended video, which must have rank number, but I'm not getting anything in return. So, you have to do something about that. So what I did was that I actually now went through it and I used the map function and I passed the video and I did some shenanigans here and I used map.random to assign a rank to the videos, and I returned recommended videos. If not, this is not going to work, right? So I'm trying as much as possible not to get all of this complexity in the way of what I'm trying to explain. But basically, if we had to actually have an algorithm working and everything working like that, probably if you go to YouTube back and you see like 10,000 lines of codes. But this is me trying to bring in a real scenario of how you can have complex things happening together. And because you may miss the type, you may not have like it going according to the way you want it to go, right? And because we had this type explicitly, mentioned here, and we have this type meaning that I have to return the right thing, my algorithm is flawless and is working perfectly. Don't judge me. Okay, so another thing that we may want to do is that, okay, for a YouTube video, we want to be able to have like comments, right? And the comments should basically not be, because comments, with the comments, you have like the person that commented, the name, the message, and all of that. So what we want to do is that in this case, we're going to use, for the sake of examples, we're going to use the type, and we're going to give the type comments for the sake of variety, so that you get to recall the things that I've been talking about so far. So for the comments, we have to have the name of the person that commented. Sorry, we need to have the user, so that we can actually use a user that already exists, a user type that already exists, which is the user. So I can come here and use user because user already exists. So as you can see, I can use a type in an interface and an interface in a type. So you can use it interchangeably like that. So we can have the comment with a string. Let's have a timestamp, timestamp, timestamp. Timestamp will just be like the time that was sent and all of that. Let's give it a string. But now I want to introduce something that we've also spoken about, which is like having specific values that we are checking. So if this person is, let's say, email, let's say we're restricting just females to comment. So if we're saying male, so sorry, gender of whoever is commenting, I think that should be under users. But let's just let's say the comments. How can we restrict this for the comments? So okay, let's say new boolean. Let's use a boolean. So let's say it's new, but let's give this multiple values. Let's say yes. Let's use yes and no. Yes, yes and no. Perfect example. So once you use, instead of booleans, once use like it's new, so that I can actually show you how we can actually specify like actual values. Let's add a maybe, right? A maybe, and let's see how we can be able to use this, you know, in our other interface here, which is the YouTube video. The YouTube video has a comment. Instead of me using comments, I want to use comment array. Remember that we're not using just comments, right? Let me make this singular because it's just a comment. I want to use comment array. And I'm getting an issue here because it's saying that duplicate identifier. Where else am I using comment? Let me search for it. Means okay, so I wonder why we have this issue here. But anyways, I think that if I probably use an interface, that should fix things. If I use an interface, does that fix things? Yes, it fixes things. So apparently, if I'm using a type like this, if I'm using a type like this, I cannot really infer it in an interface. So you can use an interface in a type like we have user here, but you cannot use a type in an interface. So yeah, if we have to do that, we'll have to change this to an interface. So I think that the person that asked the question about interface can now get like a clearer picture. So we have comments and we can have like comments here. So we have a comment array. So let's say, for example, wanted to be sure that the person that is using the comments, the whatever is going to be the comment section has to be either he has to have a user, he has to have a legit user. It means that the legit user has to come here and have like a name, email, and all of that. He has to have like a comment and all of that, timestamp. He has to, it's new, either has to be yes, no, maybe. If I come and put a boolean here, like true or false, it's going to be wrong. If I can come and put something else, also going to be wrong. So if we have to construct a YouTube video which has like, sorry, what should we create? So let's create a user, for example. Let's create a user. If I have to create a user, the user is going to be a very large object that needs to validate all of the types that it's actually inferring from. So so we're going to have like const user, and the user, let's say it's a user type. So let TypeScript guide us. The name is going to be Ferdinand. My VS Code has fallen in love with Ferdinand. And he has to have an age, email, that's the email. He has to have a password. He has to have videos. I don't want the videos to be empty. So inside the videos, I need to have a legit YouTube video from the class that we just created. We should have a title. And I want you to also realize how VS Code actually helps me to finish up the types. So you realize that it actually tells me that it actually has author, comment, likes, thumbnails, URL, views. Like this is me writing TypeScript already, like defining that this is how it should be, and VS Code helping me everywhere to remember that don't forget author because you actually wrote author. So we have all of those things, author and all of that. And I think that we will have an issue here because I think we may be missing a type, maybe missing something. URL, yes, we don't have a URL. And it has comments as well, interesting. So as you see, things just keep getting deeper and deeper. I think we have something missed here as well. Let me check it out. Something is missed. Quick fix, add missing properties. So before, after data, blah blah. What the hell is this? Append data, blah blah blah. Let me check this out. Let me check why we are having issues at the level of comments. So comment has user, he has comment, he has time, and he has is new. So we have a comment array here, which has the user, we have this, we have that. So for comments, it should be an array. I wonder why we are having an error down here. But just to be sure, we have the closing bracket, we have this bracket, and yeah, I really wonder why we have this. It's given a bunch of other properties. I don't know why this is why it is. But I'll probably have to check more on that. Yeah, I'll have to check more on that. Why that's giving that issue. What else do we have left? So I think that's basically it for the user. Okay, so we have comments. Comments have comments array. We have the user. We have the user's name, age, email, password, videos. Then we have a comment here, which has this. The timestamp we have is new, and I think this should sort it out. Let me try running this and just to be sure that we are having the right errors where we have the right errors. Index.ts. Okay, so it's yes. We have an error at the level of it's yes. We have a bracket here. Is this bracket not supposed to be here? Let me get rid of this for a bit. Let's see what we have. Okay, so if we have an empty comment, recommend. Oh, I think that there's a bracket that is missing somewhere. That's why. If we check, does this close? This closes. Does this close? This closes. Does this close? This closes. Does this close? It closes. This closes as well. So let's check this. This here. This closes 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 here. So I really wonder why we have this issue. But basically, I'll probably have to look deep into why we are having this issue. But this is basically how the structure should look like. And yeah, this is how we deal with multiple things together. We're also having an error here. So I'm trying to figure out where this error is coming from. I think it's when we run the code. So if I get rid of this, the error disappears. Okay, cool. So maybe that we have a little error here with the structure. I'll figure out more why that is, but it should be a minor issue. Yeah. But anyways, this is basically how we use TypeScript. Like in large projects, you actually have a lot of nesting of interfaces and types, and you have a lot of functions using types here and here. And I really hope that you've been able to understand like where we use TypeScript and how you can be able to use TypeScript to make your life easier as a developer. So yeah, I don't know if you have any questions so that we can be able to round up. I know that we've actually gone beyond the time. But I hope that the time was also worth it learning about how we can be able to use TypeScript and all of that. Yeah. So any questions? Any questions? Any questions so far? Okay, so I've a little theory why this is the way it is. I have a little theory. So yeah, that's the reason. Apparently, comment is also a certain type that is used, or a certain value that is used by default by TypeScript. So we don't have to like reuse it. So we have that issue here. So by removing that, everything works according to plan. Yeah. But anyways, yeah. Any questions so far? I hope everything has been understood, and I hope that you guys learned a lot from the session. Yeah. All right. I think Mr. Martin, you can take it over from here. Then we can see how to part ways. But thank you guys so much for having me.
Thank you so very much, Desmond. Thank you for making out time to give us this very, very important tutorial or introduction to TypeScript. I'm sure the participants have really learned a lot, and they are going to definitely putting this into practice during their subsequent projects. This recording, so I'm going to stop the recording now, and it was going to be available on both YouTube